Okay, welcome to our workshop on getting started with R. Let me talk first a little bit about myself. So I work for the Informatics and GIS statewide program. We are a program within the UC Division of Ag and Natural Resources. More than half you are also from ANR, but for those of you who are joining from other organizations, we are part of the UC system, and we are the part that provides research and extension services across the state of California to growers, to land managers, to people working with policy, youth education, a whole range of programs, community and economic development. And we have offices across all of the California and all of the counties. We have clusters of faculty on 5 of the UC campuses. We have a network of field stations and a whole bunch of these statewide programs, some of which you've probably heard of, like 4-H and Master Gardeners. These are very popular public-facing programs. I work for the Informatics and GIS group. And this is my team here. We are growing, which is wonderful. And essentially, we are a statewide program, and our goal and privilege is to provide geospatial and data science support for the entire ANR network. And these are the team members up here. And the kinds of stuff we do is we have services, anything dealing with GIS. We also have a drone program if you need drone data collection or drone analysis or just help designing your drone program. We enjoy doing that kind of stuff. We can build web apps for mobile data collection. We had these workshops, a bunch of different workshops that we do every semester. And we also have office hours. I'd like to give a shout out to the office hours because this is a good way to catch us. And we are here to talk about anything that's related to any of these topics, anything related to GIS or working with data, working with programming. So please feel free to grab us. We enjoy talking about these things. Monday and Tuesday afternoons, there is a sign-up link on our website. And this is open to anyone in the ANR community, including workshop alumni. So take advantage of that. And 5 minutes can go a long way in helping to get through a bottleneck. I would also like to pause here and give a shout out to my colleagues, Ben Satzman and Genoa Stars, who are with us today and helping to facilitate the workshop in the background. Ben, do you want to say a quick hi?
Yeah, I'll say a quick hi. I'm sorry if you can hear the lawnmower in the background. But yeah, my name is Ben Satzman. I am a somewhat recent graduate of Cal, studying conservation resource studies with a big focus in GIS and more so web mapping and stuff like R-related projects, thanks to Andy. So happy to be here. We'll be in the background helping out if you have any questions.
And Genoa.
Hello, everybody. My name's Genoa. I am a very new hire here, but just finished my master's degree at UC Berkeley, working on kind of a climate and fire modeling project based in Napa and Sonoma counties. And I did a lot of that work in R and ARC. And so I'm excited to help Andy share some of that with you guys today.
All right, excellent. Yeah, thank you both. And in terms of everyone else, this is a little bit of some statistics about where people who registered for the workshop series are coming from. So most people have little or no experience with R, which is great. That's what we're going to cover today, so that you're in the right place. In terms of where people are coming from, in terms of organizationally, here we can see people's emails. So we are an ANR program, and we do these things for ANR colleagues and UC Davis, Berkeley, Merced. These are some of our other campuses, and we have a few other folks. So everybody is welcome. Glad you're here. In terms of where people are hailing from, mostly the West Coast. We do have somebody who registered from Hawaii. Welcome to you. And you might be curious, but this web map is actually built in R using a package called Leaflet. And you kind of see where folks are coming from and mostly in California and a few folks from up in Washington. So great to see that. Great to see that kind of distribution. Yes, so we don't really have time to do like go around and do introductions, but during the breaks, if you feel like to chat about anything, feel free to use the chat window to ask questions or say hi to folks. All right, so let's talk about our workshop and what we're hoping to do. In general, learning something like R, the goal is to get you wherever you're starting from in the direction of becoming more functional. So just wherever you're beginning, if it's just brand new or you're a little bit rusty, moving in that direction towards getting more efficient with it. And essentially what I'll be working on or covering in the workshop series will be discussing and presenting some of the, what I would think of as foundational concepts and terminology, which might seem pedantic, it might seem uninteresting, but I do this because understanding kind of the underlying concepts and will help you both interpret code that you find on the internet or you find in the help files. And if you do have a question and you do look at a help file or you Google it or you talk to a colleague, knowing the terminology and kind of the underlying concepts, I believe will be helpful to help you kind of accelerate and keep learning on your own. All right, so the slide decks will cover a lot of that kind of background stuff. We will definitely see some hands-on practice. Today, it's going to be live coding. So get your fingers warmed up because I'm going to be typing and asking you to type along with me, starting in about 5 or 10 minutes. RStudio is the program that we will be using to work with R today. It's a lovely program. It has lots of convenience functions and can really accelerate your productivity working with R. So we'll talk about that, get some experience with it, talk about some of its functions. And again, learning how to get help is one of them. Including, I would say, ChatGPT is actually a really good resource for getting help. We're not going to go there today because I want you to get some grounded experience working with the basic syntax, which will help you understand and ask a good question to ChatGPT. But in general, the resources for getting help are just improving all the time. And here's kind of a pie chart of roughly the content. I am hoping we'll get lots of coding practice today. I mean, I think that's just the best way to learn a programming language. Even if you don't understand every single detail, it's a good way to get going. And some general learning tips are, if you're feeling overwhelmed or you're 27 steps behind, feel free to just kind of step back and watch. Also, if you're not planning to use R like in the immediate future, this is kind of stuff that you do have to practice to retain it. So feel free to just watch and kind of get the big picture and have some resources that you can go back to. If you are taking all of the other workshops in this series, I would suggest review anything that's new to you, within the next 24 or 48 hours. That's just a good learning strategy for new material that's not familiar. Before it gets stale. 1 week can go by and pretty quickly. So here's the other sessions in the workshop series. So today we'll really just be getting started typing in some basic syntax. Next week, we'll be looking more at working with packages and then using the functions that R provides, because that's really where the superpowers come in. The third session will really be looking at methods for data wrangling. And that's where you import some data, a CSV file or some sort of tabular data, and you need to manipulate it. You need to clean it up. You need to fix things up to get it ready for some kind of analysis or some kind of visualization. That's where a lot of the pain for working with data in general is finding data and getting it ready for your analysis or for your visualization. R is really strong in that. I think you'll like that. And then part 4, we'll kind of bring some of this together and talk about ways for automation, automating workflows, and then plotting using a package called ggplot. Okay. This link will take you to a web page that shows other resources that you can use to get going with R. One of the things R has going for it is that there's lots of resources out there to help you learn how to use it. All right, so it's not hard to find resources for learning R. Okay, so I don't see any questions here, so we'll keep proceeding. Why is R popular? It's really gone viral in some fields, including most of the life sciences, I would add. It's popular because A, it's open source and therefore free, right? So that's helpful. Also because it's open source, it has a really large user community, as many open source projects have, like QGIS and Python. These are all open source. And especially academics really dig this. And they're creative and they're developing new methods. So the R ecosystem, the Python ecosystem has really been developed by the user community. And R in particular has done a really nice job building in ways that someone can share their work with the R universe, and that's largely packages. Speaking of packages, there's lots of them. There's thousands of them out there that extend the capabilities of R. We'll be looking at those more next week, but it's the ones that we'll be using. We'll look at how you find some packages, but there's some extremely well-developed packages. I would say R, compared to Python, compared to Tableau, which is not open source, but compared to some of the other platforms for working with data, it's quite strong in plotting. So any kind of visualization you might want, you can probably do it in R. It's quite strong in reporting as well. So this slide deck is actually created in R. And if anyone's interested in how you do that, I'd be happy to talk to you about that. But creating notebooks, I know a lot of faculty who do all of their writing, all of their manuscripts, whether it's computational or not, they use R just because it's really well developed for that. It's miserable to learn. I won't kid you there. You know, if this is new to you, if you've been working with Excel all your life, there's a hump to get through. Coding it's just a different way of working with data, a different way of working with analyses. But once you get over that hump, you can actually work really quite efficiently. It might take a while there, and you definitely won't feel efficient at the beginning, but it is worth pushing forward because just being able to do things like data wrangling, automating workflow, automating different types of statistical analyses, you can do that really efficiently once you figure it out. Mentioned about it makes it really easy and robust to get your code out there, which is why a lot of academics like to use it. My first project with R was developing an R package for a home range analysis method that I worked on with my advisor as a grad student. And my advisor said, you know, if you want people to cite your paper, which is what all academics want, then you have to make your methods, and it was basically a methods paper, you have to make it easy for people to find it and use it. And that's the box that R checks. So it took me a while longer to convert all that into R, but I'm glad I did, because my method, it's a pretty well cited paper out there, and it's not the most brilliant or cutting edge algorithm for home range analysis, but it has its niche, and people are still using it. And R is it's a really good programming language. You can do a lot more than data analysis with R. And to be honest, probably 85% of my work, I use R every day, but probably 85% of what I do is not data analysis. It's data wrangling, it's building web apps, it's building decks and stuff like that. So R has a lot of popular features. Let's talk about the difference between R and RStudio, because these are two things that are not the same. R is the programming language that you can use to write scripts, and it's also the underlying software that those scripts run on. Scripts or commands. You don't have to use scripts. We won't be using scripts today. Actually, we will be using them in the second half. But writing the commands. R is not that old. If you compare it to SPSS or SAS or S or some of the other languages out there, even Python, it's pretty young. It's only its first beta version came out in the early 2000s, but it was well designed, has some nice features, and just kind of took off in specific fields. So there's lots of these user contributed packages. If you're really interested in seeing these numbers, I'll put a link in the chat window later. But anyway, there's lots of user contributed packages, which, as I mentioned, extend the capabilities of R. A lot of academics will package up their new method or a set of methods to work with a certain type of data in the packages. We'll talk more about that. RStudio is also really new. RStudio is only about, what's that, maybe 7 years old. RStudio is not a programming language. It's a tool. It's a program that you can use to work with R. And we'll talk about some of the reasons why people like to use RStudio in a minute, because we're going to use it in a minute. But you need R to run RStudio. So if you're installing them yourself, you have to install them both. Usually you do R first and then install RStudio. But you can use R without RStudio, and some people do. All right. Let's talk a little bit about Posit Cloud, which used to be called RStudio Cloud. We will be using this today. This is a virtual environment from Posit, which is the company that builds RStudio. They used to be called RStudio, but now they do more than just R. And it basically lets you run RStudio in your browser. And they have a very generous free tier, 25 per hours per month. So it is a good way to get going with R. I like using it for workshops because it avoids people having to install their own software and deal with packages and that kind of stuff. It is very similar to RStudio Desktop, right? So if you do want to run RStudio on your laptop, most people would use RStudio Desktop. There's a few differences when you're working on the cloud. We'll cover those when we get there. All right. Okay, so any questions on that quick intro to R? We're actually doing pretty well on time despite the delay. Okay, so if there are no questions, everybody, I'm going to put this link in the chat window, and everybody click on this link in the chat window. And what this will do, it's going to open up in your browser, Posit Cloud. You will be asked to log in if you are not already logged in your browser. If you have not yet created an account on Posit Cloud, do so now. It only takes a minute. You can either use your Google credentials or you can type in any old email address and a password, and then come back and click on this link again. When you click on this link, after you've got yourself logged in, it's going to open up a project, which I created for you. And so it's going to open up that project in your Posit Cloud workspace. But it's not going to save it automatically for you. So the first thing you should do once the project opens or deploys, which takes a minute, is to click the button that says Save a Permanent Copy. All right. So once you see RStudio pop up, go ahead and click Save a Permanent Copy. And then maybe put your thumbs up in your Zoom window, just so we get a sense of who's been successful getting that up. I will pause 2 or 3 minutes, so don't freak out if you're creating your account right now. But we'll get going in a second, and we're going to start off with some live coding. Conversely, if anyone is having challenges creating their Posit Cloud account or opening up this link that I put in there, put a note in the chat window or unmute yourself, and we'll see what we can do. Ideally, you will be able to see, you will have Posit Cloud opening up in your browser. Ideally, you can also see my screen share, maybe because I'm going to be typing in here and I'm going to ask you to type what I type. I will verbally say what I'm typing. So if you absolutely have a single tiny laptop and you're, it's hard to show 2 screens at once, definitely get that. Okay, it looks like most people have got it. And of course, you feel free to watch. Before we jump into getting used to RStudio, let's talk a little bit about what we see here. All right. So once it opens up, what you'll see 4 panes. And one of the reasons people like to use RStudio is that because it has these 4 panes, because when you're working with R and other programming languages, there's lots of windows that pop up all the time. And before RStudio, these could be like all over your desktop. So, you'll be typing, there's a console, that's the one in the lower left-hand corner. And that's where we'll use it in a second here. That's where like type a command, like I could type 1 + 1 at the console and hit enter, and it returns the value 2, right? So that's the console. That's like the live part. A lot of times when you're working in R, after you've gotten a little bit comfortable, instead of typing at the console, you're going to put your commands in a script that you can then save and use it next time. The window above the console, which may not be open. If it's not open, just click the little minimize button or the restore button and you'll see it. But that's the script or source window. So we'll be using that also today. Over on the right-hand side, we have on the bottom right-hand side, you can see there's another window and it's got a pane or tab for files and plots and packages. We will be getting to those. But as you can imagine, when you're working with R, you might want to make a plot. You might need to install a package. You might want to open a file. That's what those tabs are for, right? So they're convenience functions. So we'll be working with those. And then above that pane is another window that says with a tab called environment, history, and so on. Again, those are more like convenience functions. And we'll talk about what they do as we go along. Okay, Nicole says she doesn't see a script pane. So if I close your script pane, or your RStudio might look like mine right now, where the source window is minimized. So if it is like this, and you don't need it, we're not going to need it right now. So don't worry if you don't see that source window. But there's the little window restore button that you can click on to open up that source window, and then you'll see a blank script that you can start working in. But we're not going to do that right now. So I'm going to go ahead and maximize my console window so it fills up the entire screen on the left-hand side. And we're going to go into our first little exercise, which is called using R like a fancy calculator. All right. So I've already typed in at the console 1 + 1 and hit enter. So if you haven't done that, go ahead and do that. So this is an example where what I've done is you type in this case, a simple mathematical expression, and you hit enter and R will evaluate it. Okay, let's do a couple more. So I can say 3 times 7 using the asterisk character as the times symbol. So mathematical operators in R are mostly the same as Excel. So if you've worked with Excel, these are mostly the same. So 3 times 7, I would hit enter. It tells me that's 21. I could say 4 to the power 4 and hit enter, and that gives me 256. So the caret symbol is for exponentiation. Now, you may or may not have noticed here, but I'm being a little bit inconsistent about the white space, right? So when you're typing mathematical expressions in R, white space is ignored. And white space is ignored most of the time in R. So people have different preferences, whether to put space around the plus sign, around the divide sign, but that's totally up to you, and it's largely for readability. All right, so it's your choice whether or not to put things around, put white space around the characters. Okay, let's do a couple more. So I could say 3 + 5 raised to the power 2 and hit enter. It gives me 28. So you might remember order of operations from Excel or from algebra class for that matter. R does follow the order of operations. I think the acronym that I learned in high school was PEDMOS, so parentheses, exponentiation, multiplication, division, addition, and subtraction. So anyway, that's a little detail. You don't really need to know about it, but basically, like Excel and like algebra, R has a specific way of, it expects certain things, and it will interpret, or it'll evaluate what you type in a very specific way. So one of the things you need to know, that R uses the order of operations. That's one of the rules that you should be aware of. If I did want it to add 3 plus 5 first, I could type open parentheses, 3 plus 5, and then outside the parentheses, put raised to the power 2 and hit enter. And it gives me 64. Okay. You may have noticed when you type the open parentheses, RStudio automatically added the closed parentheses. That's a convenience function. Most people like it. You can turn that off if it's annoying, if you prefer to type all your parentheses yourself. These are little simple expressions. It doesn't really matter. But in general, that autocomplete, when you're typing parentheses or curly braces or something like that, in general, that's helpful because that's where you can get kind of stuck. Next, at the console, I'm going to type the words PI, and I hit enter, and it shows me 3.141593. So this is an example of a constant. R does have some constants built in, such as the number pi. There's a handful of them. And some packages also have constants built in. We're not talking about packages just yet, but sometimes when you install a package, maybe it's for a certain kind of statistical method or a cleaning thing, some packages will give other constants. Okay, constants can also be used just like a number. So I could type here pi times 5 raised to the power 2 and hit enter, and it will evaluate that. Again, it's going to do exponentiation before it does multiplication. All right, so pi times 25 is how that's evaluated. Okay, so here is the first challenge question for you. And I'm going to type in the challenge question at the console just so you can see what it is. But your task here, and you don't have to write this comment, but you could. It says write an expression. So this is your turn to write something that returns the area of a circle with diameter 20. All right. And the hint is area equals pi times radius squared. All right. So in case you haven't taken geometry in a little while, pi r squared is the formula for the area of a circle. And I want you to type in an expression and hit enter that will compute the area of a circle whose diameter is 20. And another hint is, in case you're really rusty with geometry, that the diameter equals to 2 times the radius, twice the radius. All right. All right. Several people are saying 314. That looks good to me. So this is not too hard. You certainly, so again, pi r squared is going to be our formula. You don't have to type it in exactly that order, but I'll say pi times, now r for the radius is going to be the diameter divided by 2. So that might be a tricky part. So I'm going to put that in parentheses here, 20 divided by 2. And then that has to be squared. All right. So I'll go ahead and put this in the chat window. There are other ways you could have done this, but again, the point is you got to compute the radius by taking half the diameter and then slot that into pi r squared. Okay, let's keep going. If you didn't get that, because geometry is just not your jam, no worries. Okay, so let's keep going. Next, so what we have done now so far is we're basically using R as a glorified calculator. That's handy, but probably there's other ways we could do that. But when you're working with programming in general, most people don't type in commands and hit enter. They save the results of commands to objects or variables. So next, I'm going to type here at the console. I'm going to type x equals to 2 times 7 and hit enter. x equals 2 times 7 and hit enter. So I notice a couple things here. Number one, it didn't report back 14, right? So what we're doing here, it's a little bit different. We are computing 2 times 7, but because we have x equals 2, essentially we are assigning the value of 14 to x. So when you type a command that assigns the value to something, in this case it's a number, and hit enter at the console, it will not print out the result of that. If we want to see what x is, I can just type x all by itself and hit enter. All right. So when I type x all by itself and hit enter, it shows me the value of x. All right. So again, we have write an expression that assigned the value to an object called x. We didn't have to declare x initially. Some programming languages do that. R does it on the fly. Right. You may also notice in the environment tab up in the upper right-hand pane or window, we see X is listed there as one of the objects in memory. All right. I use the word object and variable interchangeably. The more general term is object, so I'll try to use that the most. Okay, so now we have an object called X in memory. I'm going to make another one. I'm going to type here at the console y equals to 3 plus 4 and hit enter, and I can take y by itself just to see what that looks like. So now we have objects in memory, x and y. They're both little numbers, but I can use them together in subsequent expressions. So if I type at the console x plus y and hit enter, it shows me 21. And I can say x plus y raised to the power 7 or something like that. I get a big number. So once you create objects in memory, you can use them in subsequent expressions. Okay, so now what happens if I make a boo-boo and I type in here x equals to 5 plus, but then I'm a little bit quick on the trigger and I hit enter right now. And I see another plus sign and I think, well, that's annoying. And I keep hitting enter and I just keep seeing that plus sign. So when this happens to you, don't pull your hair out. What this means is that basically you haven't finished typing in a full command. So that little plus sign is basically RStudio is saying, could you please finish this command? So I could type in another number and hit 4, and now the command is finished. And I could look at Z and then that sees what it is. So if you see that plus sign, either finish the command or you can hit escape. And that'll take you back to the console prompt. All right, that's a common gotcha. It happens to everybody. This is an easy example. I can quickly tell, oh yeah, I forgot the second number. But sometimes you're missing a parentheses or something like that, and it can be really frustrating to kind of figure out what's missing. So just hit escape and then try again. Okay, very good. So now I have at least in memory X, Y, and Z. So 3 objects. And another thing that you can do with programming languages is you can change the value of these objects in memory simply by redefining them. Okay, so I have Z equals 5. If I just type here Z equals 55 and hit enter, now I have changed the value of Z. All right, so you can do that. You can even use, of course, probably no surprise, I could say Z equals to X times Y and hit enter. So you can use other objects to define the value of objects. And you can even do something like this. Z equals to Z times the raised to the power 3. Z equals to Z raised to the power 3. If this was algebra class, that wouldn't make any sense because they're different on each side of the equal sign. But here, we're using the equal sign not to test for equality, but to change the value of Z using the existing value of Z. All right, so this is something else that's common in programming languages in general, is that you can update the value of an object using its existing value as part of the expression. Okay? So that's something that's a little bit novel working with programming languages. All right, next, let's look at some comparison operators. Another key thing that you're going to likely have to do with data. All right, so I can see that x equals to 14 and y equals to 7. So if I type here x is greater than 5 and hit enter, I get back true. So that greater than symbol is, it's called it's a logical operator. Logical just means it returns a true false. Likewise, I could say y is less than 7 and it tells me false. But if I say y is less than or equal to 7, it's going to tell me true. So less than or equals to, if you use that test by using the less than sign followed by the equal sign. Okay. Again, these are called logical operators or comparison operators. And we can make them a little bit more fancy. I could say x is greater than or equals to, say, y times 2. And when I do that, really, R is doing two things. The first thing it's going to do, it's going to compute y times 2, and then it's going to compare that to x and return true or false if it's greater than or equal to. All right. So those are all pretty simple comparison operators. But we already saw if I type z equals to y, that's not going to see if z and y are the same. It's going to actually change the value of z. So if you want to test for equality, we have to use the double equal sign. So I could type here x double equal sign 14 and hit enter, and that returns true. All right, so if you want to test for equality, don't use the single equal sign, use the double equal sign. The single equal sign is the assignment operator. Now, you might think that's being a little bit verbose, and it might be, but I say that because there's other ways that you can assign the values to objects. All right, there are other assignment operators, which we'll see some of that later. Okay, any questions? All right, I hope I'm going at a okay pace, but please, if you have questions, feel free to chime in. And if this is all really basic for you, just feel free to chill out and watch, and we will get to some more advanced stuff coming up pretty soon. Okay, so far we've been only looking at simple math numbers, simple mathematical expressions, but R can also work with text. Okay, so let's create some examples of working with text. All right, so for example, I could type here, 1 second. Okay, before we look at text, let's first talk about making better object names, right? Because X, Y, and Z, you can imagine, you're doing a project and you might have like all of these variables in memory and it's confusing. Like, what was X again? What was Y again? So R allows you to use longer object names. The rules for naming objects in R are pretty liberal. Well, I'll go through some of the highlights when we get back to the next set of slides. But I could type one here, the word shoe underscore size equals to 9. All right. And again, so at this point, instead of using X or Y or Z, I've typed in shoe underscore size. This is generally a good practice to use meaningful object names when you're working with programming in general. Okay. So we just created a numeric object called shoe size. And we'll see some other examples of this. The next thing I'm going to do, though, is you might be wondering, can you, the different kinds of variables that you can make with R, or the different types. So every object in memory has a type or a class. R uses the word class. Most other programming languages use the word type. But if I type the word class, and then I type parentheses, and then in there I put shoe size, or X, it's going and hit enter, it's going to tell me that the shoe size object, it's a numeric variable. It's a numeric object. Okay. So class, that's one way that you can see the class of an object is use that class function. And you may have noticed when you typed class and then you typed open parentheses, and then we already talked about RStudio will add the close parentheses for you. But also when you start typing, then, again, at the console, I typed in the word shoe here, and it detected an object in memory called shoe size, and that's called auto suggest. And if I like it, I can just hit tab to accept that suggestion. All right. So that's called autocomplete, and it's a convenience function that RStudio provides. So, it can be very convenient, both when you're typing an expression using an object that you've already defined or that's already in memory, or when you're typing the name of a function, it'll also autocomplete or make a suggestion about the kinds of functions you could use. All right. So that's another bell and whistle. It's 99% of the time it's helpful, but it is something that you could turn off under settings. Okay, so we just created another numeric object called shoe size, but R can also create text or character objects. So I'm going to type here shoe color equals to brown, and I put brown in quotation marks. All right, so this is an example of creating a character object. In fact, if I type the word class and then shoe color, the object that I just created, and hit enter, it's going to tell me I have a character object. So shoe color is a character object. Shoe size is a numeric object. Okay, you might wonder, well, what would happen if I add these together? So shoe color plus shoe size, and I hit enter. Shoe size. What's going to happen? Well, we get an error message, right? So this is an example where it's not a surprise, right? How can you add a word to a number? Like, that's confusing for R. It would be confusing for most people in most programs. So that's an example of typing in an expression that generates an error. And this is an example of what I would say an error message, which is not really helpful. Non-numeric argument to binary operator. This is another characteristic of R that even experienced people get frustrated with, is that a lot of the error messages are a little bit cryptic. So don't feel it's you. If you do get strange error messages, a lot of times you can just Google them, just copy paste the error message into Google, and somebody else will have asked the same questions. And feel free to ask for help as well. If you get an error message which is not clear, which is often the case. Okay, just a couple more things, and then we're going to take a break. So we've already seen that we can create character objects. Let's talk about, let's look at tests for equality for character objects. So I'm going to type in here shoe underscore color, and then double equal sign, right? Because remember, double equal sign is what you use if you want to see if two things are equal. And I'll type the word in brown again, right? You may also know that RStudio, bless their heart, they have actually made the word brown, given it a brown background. That's another convenience function. I don't know how convenient it is. That's one that I normally do turn off. But when you're working with colors for like plots or making maps or stuff like that, it could be helpful. I mean, we all know what brown is, but sometimes you're typing in a color code, which is like numbers and letters. And that's in those cases, it's helpful. Let's see a little preview of that color. All right, so shoe color double equal sign brown returns true. But now I'm going to repeat that command. And here's another pro tip. Instead of just retyping it, I'm going to use the up arrow at my keyboard. And you might notice if you click the up arrow at the console, it's going to scroll through your command history, right? So that's another convenience function that RStudio provides. But let's say I change it, I can hit backspace and go in there and change the lowercase b to an uppercase B. And now I hit enter, that says it's false. So this is another characteristic of R and several other programming languages as well, that everything is case sensitive. Okay, everything is case sensitive, including the variables, the names of variables, the names of functions, the names of packages, the name, characters. Everything is case sensitive. So that's another gotcha. Particularly, eventually, it just becomes automatic. But if you do get weird error messages, it could very well be because, or check your capitalization if you're working with, like if it says function not found, check capitalization first. Okay, any questions? There's one question in the chat, which I'll address during the break. But any other questions? All right, very last thing then, before we take a break, is I'm going to type in another little bit more complicated command here. I'm going to type the word hist. This is like a teaser for what we're going to see coming up. Hist, and then I'm going to put in some parentheses, and then I'm going to type rnorm, RNORM, and again hit parentheses. So now I have two sets of parentheses, and you can see there's a little help text that tells me rnorm is a function, and inside that little yellow box, it's telling me what are the arguments to type inside the parentheses. And I'm going to type the number 1,000 and then hit enter. And it pops up this particular command that I type. It creates a histogram, and it should pop up in the plot window over on the right hand side. All right. And you might guess from the histogram and the shape of the histogram what our norm function does. But we'll answer that quiz question after the break. So let's take a 5-minute break and come back. Let's take a 7-minute break, because I know these morning sessions, people need to check email or do a bio break. So let's start at 11:10. And if people have questions, I will hang out and be happy to answer questions. You'll just unmute yourself. And otherwise, we'll see everybody at in 5 minutes, and I'll put up our little break slide. So if you are sitting at your desk, you can do little exercises. Okay, see everybody back at 11:10, 6 minutes. All right, let's keep going then. Feel free to answer any other questions in the chat window. All right, so just a quick review of what we just covered in the first half. And again, I'm kind of highlighting terminology here. Because again, I think this helps people understand and continue to learn on their own. So when you enter an expression at the console in R will evaluate that expression and print the results at the console. All right, so that's what we just saw. If you enter an incomplete expression, you get that plus sign, and you get that plus sign from hell cycle. Just hit escape and it'll go away. You can save the results or assign the results of an expression to an object or variable using an assignment operator. We've been using the single equal sign. I was just explaining the arrow operator is another one that you see quite a lot. And that's the combination of the less than and the hyphen, which kind of visually looks like an arrow. So that's another operator that you can use to assign values to objects. Objects are created on the fly. If they already exist, they are updated. The names of our objects can be named almost anything, but no hyphens or spaces, please. We're going to see some of those rules here in a second. We didn't actually look at that in the exercise, but we did see that R is case sensitive about everything. All right, so if you see error messages, and check the case of your commands. Once you create an object, you can then use it in subsequent expressions. And this is done all the time in programming, right? So you create an object and you can keep using it later down in your work. You can update your R objects as much as you want. In other words, give them a new value, just reassign them a new value. I didn't mention it, but it's worth noting that when I type x equals 1, that's creating this object in memory. I haven't saved it to disk. So it means when I close RStudio and come back tomorrow, X may not be there anymore. That's not really a bad thing, though. We'll talk about why that's not really a bad thing, particularly if I can easily create X again by repeating that command using the script, right? Because then my whole workflow becomes repeatable. But that's worth noting that these things only exist in memory until you close RStudio. RStudio does have the ability to save all of your objects in memory if you would like. I think that's turned off by default now because most data scientists think it's not. It's lazy to keep your objects in memory and never have to recreate them. Comparison operators, also called logical operators, they return true or false, and they do comparisons. Here's some of them that we looked at. We saw that R does have some constants, which they work just like an object that you make yourself, but you don't have to define them. They're ready to go as soon as you turn on R. Okay, and packages do this as well. Let's talk a little bit more about the rules for naming objects. R is pretty flexible, more flexible than other programming languages, I might add. But there are some rules. An object cannot start with a number. So 3 pieces, this would generate an error. That's, of course, not going to work. Obviously, you can't have spaces you can't have an object with spaces in them. You actually can, though, if you put the backtick characters around it. I don't recommend it, but you actually you can create objects that have spaces embedded in them if you surround them with backticks, which is the little ticky character next to the 1 key on most keyboards. But you cannot have object names that have a hyphen in them. The hyphen is the minus sign, right? So that's not going to work. And it's not illegal, but it's probably a bad idea to overwrite the value of an existing function or constant. So for example, pi is a constant. I could say pi equals to 3 or pi equals to 20, and that works. But I've just ruined pi. I can't use the default value of pi anymore. So that's generally bad practice. And there's a handful of functions, notably C, which stands for combine. We'll look at that soon. Which is also, it's not a good idea to name a variable called C, because then you lose the C function, which is actually a really handy function. In terms of the styles of how you name your objects, you can pick and choose. These 5 represent like what most people use. You may not have to worry about this right now. I would just say be consistent. I like using what's called snake case. A lot of folks like to use that. Camel case is also handy. Just you do have to be consistent about capitalization, though. If you use camel case as your kind of template or size or standard for naming objects. You can put periods inside object names too. Some people do that. I find that a little bit confusing. But it's 100% personal preference how you name your objects. Okay, we've already looked at an example of how every object in memory has a class, and that you can use the class function to see what the class is. You can also look up an environment pane. So far, we've been working with numeric objects and character objects. There are many, many others. Here are some of the common ones. I'm not going to pause right here. I will highlight, though, that when we start working with data, such as CSV files or any kind of tabular data, those are mostly going to be data frames, aka Tibble, or matrices, but generally data frames. Right? So we'll be working with those, and we'll touch back on some of these other data types as we need to. Okay, but let's talk a little bit about vectors, because vectors is another characteristic of R that other programming languages don't really have, and this is partly why it is a popular and powerful data analysis language to work with data. Right? It's this idea of vectors. So basically, a vector is it's an object, but instead of containing one number, it contains a collection of objects that are all of the same class. So all numbers, for example. And you might think, well, that just sounds confusing. How could that be helpful? But we'll see how this is helpful shortly. But let's look at an example of a vector. Okay, so again, a vector is an object that contains multiple values of the same thing, all numbers, all characters, all dates, and so forth. So we can build one, we can create a vector of integers using that colon. So 4:12, the colon is called the sequence operator, when they be technical, but the colon operator basically returns a series of numbers from the small one to the, actually not, they don't have to be smallest to largest, but from the left number to the right number. If the left number and the right number are integers, you generally get integers. You get a sequence of integers. And most of the time, that's what people are using. Okay. So again, the colon operator, but it returns, in this case, like 7 or 8 integers. But all of those are saved in I. So when I type I all by itself and hit enter to see what I has, it's showing me 8 different numbers altogether. All right. So that's an example of a vector. I is a vector of numeric values. Okay. And it doesn't have to just be numbers. You can have double is another kind of number. It's not integers, but it's, it has decimal places. You can have vectors of true false values or logical vectors, characters, and so on and so forth, right? So this is something that you probably will use quite a bit working with R, is vectors. So how do we make a vector? Well, we've already seen the colon operator can be used to create a vector of numbers. Also, there's some functions, such as the repeat function, REP, that will return a vector. In this case, it's returning a character vector of 5 values, and they're all the same. That's allowed. The vectors elements don't have to be unique. So it's basically the repeat function repeats the first argument, in this case 5 times, which is the second argument. Okay, so there's many functions that return vectors. We'll see some more that generate random numbers, a bunch of random numbers all at once. Another function that you can use to create a vector is that C function I was talking about. C stands for combine, and whatever you put inside the parentheses, you can have as many things inside that parentheses as you want. Here we have 3, and it's going to combine them together in a single vector. So here I've created a vector called yn, and it contains 3 logical values or true false values. Okay. Letters. If you type letters at the console and hit enter, you get back the uppercase letters of the English alphabet. Letters is a constant. It is a vector it's a character vector. State.abb, that stands for state abbreviations. That is another constant. It comes with R, and it contains the abbreviations of the US states. All right. It's a vector, right? It's a vector of 50 character elements. Month.name is another one, right? So constants can also be vectors. Okay, the other functions that create vectors or return vectors are unif. The R stands for random, the unif stands for uniform, and basically this function will return randomly generated numbers from 0 to 1 by default. We'll talk about how you can change those later, but it'll return, and then whatever the number inside the parentheses are, it's going to return that number of random numbers. All right. And every time you run it, you're going to get a different set of random numbers. All right. So there's a bunch of functions that return random numbers. Our unif returns uniformly distributed random numbers. Our norm returns normally distributed random numbers, so that bell curve shape. The sample function is another randomization function. And what this one wants, it expects a vector as that first argument, the first thing inside the parentheses. In this case, the names of the months. And then the second argument, it's going to pick, in this case, 3 elements at random from the names of the months. All right, so we'll see some more examples of that. But the point here is that there's a number of functions that return vectors, including all of these functions that do random selection or random number generation. Okay, so that's vectors. That's how we make them. That's what they are. But why is this useful? So let's look at how they behave which will start to give you a glimpse of why this is helpful. So a lot of the operations that you do in R, like add things together, divide things together, are vectorized, meaning if you give it two things to add, it's going to add each corresponding element if the two things you've given it are vectors. So in this little example, we have a vector called x. It's the numbers 0 to 4. We have a vector called y. It's the numbers 11 to 15. And let's look at some of the functions that we can do with these two vectors. So sine, that's a function. It returns the sine, and it's vectorized. X, we saw x has 5 values. The sine function gives us 5 sine values back. Likewise with cosine. Most of the mathematical operators are also vectorized. So here we have x plus 1. And what this will do is it's going to add the number 1 to every element of x and give us back the result, right? So x was 0 to 4. X plus 1 is now 1 to 5. You can also add two vectors together. All right, so x and y, they both have 5 elements. X plus y will add the corresponding elements to give it together and give you back the results. If x and y don't have the same number of elements, R will try to repeat the shorter one as many times as needed to match the length of the longer one. All right, so that's, we'll see, we might see some examples of that later. Okay, so that's vector functions, most vectorized functions and vectorized operators. Let's talk about some of the functions. We'll do a deeper dive into functions next week. We've already seen several functions. But I want to talk about some functions are aggregate, because that's kind of a, that takes a vector and spits out a single number, all right? So here we have, in this little example, we're creating a vector called x. It's got 20 random numbers. So we already saw that sine, cosine, addition, subtraction, those are vectorized functions, but not all functions are like that. So the mean function, which takes the average, it doesn't take the average of every element. That would be a little bit silly, right? But it's simply, so the mean function is an aggregate function, takes all of the elements of x and returns the average, right? Likewise, median, standard deviation, these are all examples of functions that take a vector and they aggregate the values into a single output, all right? So that's a different kind of function. Some functions are vectorized, some functions are aggregate. And again, we're talking mostly about functions that you use to play with numbers. Okay, and yeah, so if you do have a vector of character objects, there's a function called first, there's a function called last. These are also aggregate functions because you give it a whole bunch of characters and it returns one of them, in this case, the first one. Okay, so something else you'll probably have to do working with vectors is to learn how to subset them. Because you might have a vector, the vector might be a column from your CSV file, but you don't need all of the values. You only need to work with some of the values for your next thing, which might be an analysis, it might be exporting the data back out to disk, it might be creating a plot of some sort. Subsetting is pretty normal working with data. There's a few different ways that you can subset vectors in R. In 2 weeks, we're gonna look at the tidyverse, which is really handy for subsetting data frames. But working with vectors and using base R or just R kind of right out of the box, we can use square brackets. So square brackets will almost always work for subsetting, whether you're subsetting rows out of a data frame, or in this case, subsetting elements out of a vector. So basically, you put the square brackets after the object, and then inside the square brackets, if you pass a number or a vector of numbers, as we'll see, it will return those elements out of the vector. So letters, and then in square brackets, 2 returns the second element of letters, which again is a constant, which is the capital letter B. If I put 2:4 inside the square brackets, you might remember 2:4 returns a vector, of the numbers 2, 3, and 4. So this expression will return a vector of 3 objects, 3 characters, 3 letters. The second, B, C, and D, the second through fourth elements of letters. Okay. If I put those in reverse order, 4:2, that also works because 4:2 returns the numbers 4, 3, 2. So now I get back the fourth, third, and second elements of letters in that order, right? So you can use the square bracket notation to change the order of things, and you can use it to subset things. You can even use it to reassign the values of those elements. So like if I wanted the fourth letter of the alphabet to be something different, I could use the square bracket notation and just assign it a new value with equal sign, and then that would update the object. Okay. Daniele could not find the function first. When we get to our studio, let's double check on that. I'm not sure why it couldn't find that function. It might be part of the deep. Anyway, we'll check on that. Thank you for flagging that. So one thing you can do to subset vectors is to put square brackets with numbers inside them. You can also put inside the square brackets true false values, a vector of true false values. So here's an example where this is really cumbersome. We'd never actually do this in process or in for a real project. But here in this example showing inside the square brackets is the combine function with a lot of true false values inside there. And again, the combine function takes all those true false values separated by commas and returns them as a single vector with those values. And if you do pass inside the square brackets true false values, it will return the corresponding values from the object that are true. Right. So in this case, you can see there's a bunch of trues at the beginning. So we're just getting that. Now in practice, you're probably not going to type in a really complicated expression with the C function. You might in some circumstances, but the other thing you could do inside the square brackets is you can type in one of those conditional expressions, right? X is greater than 5, for example. You could put X is greater than 5 inside the square brackets. That's going to return true or false, right? You might have X could be 1,000 numbers. X is greater than 5 is going to give you 1,000 true false values. You put that inside the square brackets and hit enter with X on the outside, and you'll get back those values of X that are greater than 5. All right. Here's an example using a string notation. Okay. Finally, the other thing that we'll do in the next exercise is make some plots, because when you're working with data, most of the time we'll probably want to see the distribution of your data, particularly if they're numeric data. We've already seen hist. Hist generates a histogram, and you just pass it a vector of numbers. In this case, 500 normally distributed values, and it creates a nice little histogram. It's got some default shading. It's got some default bin widths. It gives it default colors, the default labels for the axes. All that stuff can be modified with extra arguments. We're not going to do that, though. We're just going to make the basic plots today. In 3 weeks, we'll do a much deeper dive into making much nicer looking plots. Okay, so that's hist. Box plot. You might remember box plots from your stats class. Also generates, also accepts a single vector of numbers. Right, so these are one-dimensional plots that make sort of summaries of your data. If you have two numbers, that you can make a scatter plot. So here we have X and here we have Y, and we can make a scatter plot using the plot function. All right, so we're looking at hist, box plot, and then plot for making two-dimensional scatter plots. We could also connect the dots here and turn this into a line plot, which I think we'll see that in the exercise. Oh, here we go. Here's one already. Yes, so here we're making a line plot, and it looks just like that scatter plot that we just made. But the one thing that's added inside is type equals B. B stands for both, which tells it to both, put both the dots at the points as well as connect the dots with the lines. Okay, so that's how you make, that's one way you can make a line plot. Okay, excellent. In the next exercise, we're actually going to be working in the script window instead of the console window. Now, you might wonder, why do we do this? Well, hopefully you did get a little bit frustrated working at the console window. Most people do. It's clunky. You know, you can use the up arrow to go back to your previous command, but if you have to make a change, you have to like backspace, 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 and then retype it again. The script window, it's easier to write your code that way. All right. So that's one reason people use scripts. One reason our next exercise will be using scripts. Another advantage of working in scripts is you can put in comments to remind yourself what each step is doing. Comments are not run, they're just comments, but so R will ignore them, but they're extremely helpful and best practice. Working in scripts is like working in Notepad, right? You can copy paste it, you can email it to yourself, you can email it to a colleague, you can save the file with a new name and then open it and modify it. You can reuse your code. This is what people like to do. This is you need to do this if you want to get the power of working in a programming environment. You know, getting the pattern of reusing code. Very few people, myself included, write code from scratch. I might do some basic stuff, but a lot of us, you know, we just have the text files or where we go back and find a snippet of code that does something. Something else you can do in scripts that you can't do very easily at the console is make loops. We'll cover that in about 3 weeks, but that's really powerful. And yeah, you can officially tell people that you're coding because that's what working in scripts are. You know, it's the essence of coding. All right. Okay. Any questions before we jump into the next exercise? All right, go ahead and switch over to Posit Cloud. Click on the Posit Cloud tab in your browser, and your project probably went to sleep. That's a good thing because, again, you get 25 hours per month. So I think it goes to sleep after 10 or 15 minutes. You can change that if you're in the pattern of stepping away for a while. I'll go ahead and open up the project. And before we do anything, we're going to do best practices here, and we're going to like clean out our RStudio, right? Pretending that we're doing our reproducible workflow. Reproducible workflows basically mean every time you start working, your script that you're building does the whole analysis. We're importing the data, cleaning the data, and that's what we're kind of emulating here. So how do I clean out my RStudio? So the first thing I'm going to do, you might notice there's a little broom icon in the console. All right, I'll highlight that one. You go ahead and click there. That's going to clean out your console. There's another broom icon in the environment pane. So I'm going to click on that one, and that's going to delete all of the objects that I created in memory. And there's even a little broom icon down by the plot window. That plot's not hurting anything, but I'm just to be complete, I'm going to clean that out as well. Okay, so at this point, go ahead and make sure that your source window above that console is visible. And you should be able to click in there and start typing. It should say Untitled 1. So basically, this is a blank script. All right, so the very first thing we'll do is to save this script, because that's the whole point of working with scripts, is to get to save it. Where to tap Posit Cloud? Okay, so there's so to go into Posit Cloud, that's a good question. You can go back to your browser. If you still have the Posit Cloud open from the first part of the workshop, just click on it again and clean it out. If you close that browser, then just open up the browser again and type posit.cloud, and it'll take you to the Posit Cloud website. And then when you first get into Posit Cloud, this is my Posit Cloud account or Posit Cloud workspace, and all the projects that you got going will appear here. I've got a bunch of them. You probably just have the one that will started this morning. Unless you didn't save that, unless you forgot to click the save a permanent copy, in which case just create a new project for right now. Okay. Yeah, and is anyone else having challenges getting back into Posit Cloud? Feel free to put a note in the chat window. You can go into a breakout room with Ben or Genoa if necessary. All right, I'm assuming most people got it. So the first thing we should do is save this script. It's blank, but let's go ahead and save it. So you'll see there's a little save button, right? It says save the current document, and it's asking me for a file name. So I'm just going to call this exercise 2, and I'm going to hit enter. All right. You can call it anything you want. A couple things I'll highlight. I did not type when I saved it .r. .r is the default extension for an R script. It's uppercase R. But it's basically, it's a text file. I could download this and open it in Notepad or use any any text editor. You might also wonder, well, where is it? Because I saved it. Well, it's not on your hard drive because, again, we're working in the cloud. But if you click on the Files pane, you should see exercise 2.r. And I haven't typed anything yet, so it's 0 bytes. But that's where it gets saved. So this virtual environment you're working on, it's like a desktop. It's like working on a foreign, another computer that's out in some data center somewhere. Probably in Utah, because that's where electricity is cheap. A lot of data centers out there. If you do want to download this script to your hard drive, which I would recommend, not right now because it's empty, you simply check the box next to it in the RStudio Files pane, and then I think you go up to the More button in the Files pane toolbar and click Export. I'm not going to do it right now. And this will allow you to download this R file, which is, again, it's just a text file, to your hard drive, and then you can open it later. You can keep a copy of it forever. You can open it up in RStudio in your local environment and keep working with it. Okay, excellent. All right, let's keep going then. So in this little next exercise, I want you to type, again, it's going to be type what Andy types in the source window. I won't make you type from scratch for the rest of the workshop series. But I do want you to get the in the pattern of typing it in a script. That's why we're going to do this as live coding again. All right, so the theme, so I click here in my source window. I'm just going to start typing. I'm going to type in some comments. If you're a slow typer or you don't want to do this, that's fine. I will send you out this R file later. So if you don't want to type in everything, you just want to watch, that's fine too. Okay, but here let's make some vectors. Let's make some vectors. So take note that I started that comment on line 1 here with the pound or hash character, right? So if you do want to make a comment, and it is a good idea to comment your scripts, just put the pound sign. 1 is enough. I will often do 2. But that tells R that this is a comment. It's not going to try to run it. Okay, the next thing I'm going to do here, and again, blank spaces are generally ignored. Blank lines are generally ignored. So I'm going to make a vector called A. A equals to 1:10. All right. So I just typed in my first command in my script, A equals 1:10. So you might wonder, okay, well, did it run it? Well, it did not run it yet. To run a command in your script, the cursor needs to be blinking on that line, or you could highlight the line if you want. You don't need to. And then you can click, you see there's a little run button in your source window. If you click that, that will run the current line. And if you look down at your console, assuming it's open and not completely minimized, but open it a little bit, you can actually see when you run a command, that basically means copy the command down to the console and hit enter, right? So that's when you run a command from a script, that's basically what's going on. It's taking that command, moving it down to the console and executing it, right? And just like before, when we typed at the console, A equals 1:10 does not show me the value of A because I'm assigning a value to A. I'm not printing it at the console. So I could type A by itself in my script and again, hit the run button and it will show me the results of A. It'll print out the results of A at the console. Okay, let's make another vector called B. B equals to 30:1. And then I'm going to run that. And then I'm going to type B by itself and run that. 30:1 generates the numbers 30 down to 1. Right? So that's going backwards. And then finally, let's do another, let's make another vector. Those two vectors, A and B, we use the colon operator to get a sequence of numbers. But let's use that C function I was talking about. So I'm going to say my next one's going to be E equal sign and then C. And then inside C, I'm going to take the numbers 100 and the number 500 and then run that. Now, if you're feeling tiresome of clicking the run button all the time, a little pro keyboard shortcut is you can also use Control Enter. So when you're clicked in at the console at the source window and you hit Control Enter, it will run whichever command the cursor is blinking at. Another pro tip is if you do want to run a bunch of commands at once, you can simply highlight them, select them with the keyboard or with the mouse, and then hit Run button or Control Enter, and it's going to run them all at once. Okay, so at this point, I have 3 objects in memory, A, B, and E. Let's make one more. This one's going to be a little bit bigger, though, right? So I'm going to say F equals to 20:150, and then I'm going to hit Control Enter on my keyboard here, and that created a vector called F. But now when I type F by itself and hit Enter, so F is kind of big, right? I mean, it's not that big, but it's got maybe, what, 120-ish 100 numbers in it. So when I print the value at F at the console, it's not big enough to show them all. So what it does, it's going to wrap them around. And you might have been wondering, like, what are those little numbers at the beginning of each line? Those numbers at the beginning of each line tell you the index of the first element printed on that line, right? And this will depend on how wide your window is. For me, I can get like 23 numbers on a line, and then it has to start a new line. If you made it wider or smaller, you would get a different number of numbers. But that's what those little numbers are at the beginning of each line when things are printed out at the console. Okay, any questions? Okay, somebody asked about
a question.
Yes.
What can you explain again what so E equals C and then parentheses 100 and 500? Does that mean that it's what does the comma mean?
What does the what mean?
So what is, I guess, what is that function saying to the for E?
Yeah, no, good question.
100 comma 500.
Yeah, so the C function, like, you know what I should do here? I should make my I'm going to make my font size just a little bit bigger. So I'm going to go to global options and then appearance, and then make my font size. We got to 14. Hopefully that's a little easier on the eyes for some of you. On that note, if you go to tools and then down to project options and global options, I don't want to take time right now, but you can change the colors. You can change the font size. There's some nice themes like color palettes that you can use. So feel free to play with that if you'd like. So let's go back to that C function where we're using C, and then inside the combine function, we have the numbers 100 and 500. So what that C function does, again, stands for combine. It's taking all of those arguments. In this case, it's just 2. I could type more though. I could type in 500, 6, 45. You can type in a whole bunch of numbers. And when you run that, they're not separate numbers anymore. They're all combined into a single vector called E. So now when I run E by itself, all of those numbers are saved as a vector that in this case, I just gave it, I redefined E and I typed in some extra numbers. So now there's like 6 numbers saved inside E. All right. Does that help? Yeah. So that's what that C function does. It's another way to create a vector, right? Because sometimes the colon operator doesn't work. Like you might need a vector of numbers, but they're not like sequential integers, right? And definitely when you're working with character values, like the names of files, for example, you can't use the colon operator. You almost always have to use that C operator and type in, the names of colors, the names of plants, the names of people, whatever the character data is. Okay, let's keep going here because I'm talking too much. But we're doing okay on time. Okay, so we've created a bunch of vectors. You can see them in your environment pane. So next, let's look at some other functions that are handy with vectors. So I'm going to type in the function head, H-E-A-D, lowercase, and then inside the head function, I'm going to put F and hit enter, or sorry, control enter, thank you, to run it. So what the head function does is, you might remember F, the way I've created it here, it's got 131 numbers, which a lot of times you don't need to see all of them. So the head function returns the first 6 numbers, just to kind of give you like a little glimpse of what's inside F. Of course, I could look in my environment pane as well and see the first few values there. But that's the head function. It also works and is pretty useful with data frames. Another function is called length. So I put length, and then again I put in F as the argument. The argument is what you type inside the parentheses, and that returns the length or the number of elements, in this case of F. All right. So there's a whole bunch of functions which are useful for working with vectors. Right, length being one of them. Before long, we're going to be looping through the elements of a vector, right? So you need to set up a loop to go through all the elements of vectors, and we might use length to do that. Right? Okay, let's look at some vector arithmetic. I'm just going to type here, playing with vector arithmetic. Make sure I spelled that right. Okay, so we have these vectors. So I'm going to type here x plus 50. Control enter. Oh, not x, should be a. Sorry, my bad. A plus 50, control enter, takes the objects of the elements of A, and because 50 is a single number, it's going to repeat that and add 50 to every single element of A. All right, and return the result. All right, so addition is vectorized. Let's try A plus B. A plus B. So A has 10 elements, B has 30 elements. So how's it going to handle this? Well, if you look closely, A is the numbers 1 to 10, B is the numbers 1 to 30. So basically what it's going to do is there's not enough of A to match B, so it's going to repeat the values of A as many times as needed to catch up to B. All right, so again, you can add 2 vectors together, and they can be of different sizes. And if that happens, R will simply repeat the one as many times as necessary. Now, if it can't repeat evenly, that's probably not what you want. I don't know if you'll get an error message. You might, though. It may expect them to be a multiple. The lengths might have to be a whole multiple of them. Okay, but we've seen that addition is vectorized. I'll type here A to the power 2 and hit Control Enter, see what that looks like. Okay, so exponentiation is vectorized. B divided by 2, obviously that's division, so that's vectorized. So most of these mathematical operators are going to be of different length. I could type, no, I messed up my E. I'm going to go back up. I'm going to use my command history. And actually, no, I don't have to. I want to rerun the line of code where I created E because I kind of messed it up. This is an example where it's really easy to fix a line of code or to modify a line of code if you're working in a script. I can just click up there, make the change. In this case, I want to delete some of those numbers and then run it again. Again, Control Enter runs the current line, and I just recreated E. So you can already see how working in a script is really convenient. It's easier to type in a script. You can put in the comments. You can go back up and change things, just like working in, any kind of text file. Okay, next, I'm going to put in a challenge question here for you guys. And we'll pause and let you work on that. So create a vector called X with the numbers 11 to 20. Okay. Then take the square of X. This should be easy. And then take the square root of X. The square root of X. Okay. So that's your challenge. 3 lines of code. Write a vector called X with the numbers 11 to 20. Run it. Take the square of X. Run it. And then take the square root of X and run that too, right? So you're trying to get 3 lines of code. The challenge here is that we haven't seen how to get the square root. So I'm not going to tell you, but use all your resources at your fingertips to figure out how to take the square root of X. There is no cheating when it comes to programming. You can find your answers however you, as long as they work, that's all that matters. Okay, so I'll pause for a couple minutes here and let people work on these challenge questions. All right, so just for the sake of time, we'll keep moving here. So Daniele figured out that there's a function that she could use to compute the square root, and it's SQRT. It's the same function I think that Excel uses. So if you don't, we haven't seen that before and wouldn't expect you to just kind of like guess how to find the square root function, but you could certainly Google it. You could say, how do I take a square root in R? And you would have found it. You can also, you might remember from algebra class, if you raise to the power 1/2, that's the same thing as taking the square root. And you can also start typing at the console. If you're guessing like square root, you type SQ square root. All right. So, or if you think it could be SQRT, again, when you type in 3 letters, if R finds a function that matches what you've started typing, it'll pop it up, right? So sometimes just that autocomplete text can help you find a function you use. But the bigger point though is like finding the right function is half the battle. Okay, so we only have a few minutes left. So let's we'll come back to plotting next time. Let's do some subsetting. Okay, so we've already seen that we have a vector called A. So let's practice subsetting. Okay, with square brackets specifically. So I have A, and then if I type square brackets, and then I can put a number inside the square brackets, maybe 5, and hit enter, it returns the 5th element of A. Okay, I can do the same thing with, but instead of a single number, I could put a range of numbers, say like 7:4, and then hit enter, control enter, and it returns the 7th through 4th values of A, which in this case happen to be the same numbers. Okay, so that's an example of using square numbers inside the square brackets. We can also put an expression that returns true false values, and this is done quite commonly. So here I'm going to type A and then the square brackets. And then inside the square brackets, I just give myself a little white space for readability. I'm going to type in here, A is less than 5. All right, so A is less than 5. This is going to return logical values, true, false values. And when I put that inside the square brackets and run it, I only get back the numbers that are less than 5. All right. These are all integers, so this might be a little bit anticlimactic. But let's quickly do one more example that's a little bit more interesting. Let's do B. Remember, so B is the numbers 1 to 30, and then square brackets. And then inside the square brackets, I'm going to take B and then double parentheses 3, double percent sign, and then double equal sign 0. All right, I'll put this in the chat window here because this one's a little bit counterintuitive. All right, so I'll just put that in the chat window here. Check this out, what I put there in the chat window and what I've got typed here. So inside the square brackets for B, I have B double percent sign 3. Double percent is modulus arithmetic. So it's basically the remainder of B after you divide it by 3. And when that equals to 0, so that's the next part of the expression, that's going to be true. That's going to return true. So this is essentially, this is one of the ways, it's probably a pretty quick way to get the integers that can be divided by 3 evenly, that are divisible by 3. All right. Okay, so that's just a little example, and we've run out of time, but I will send you some, I'll send some more challenge questions that you could, if you're finding this interesting and would like to do a little more practice before next week, I'll send you a little, some more questions to work on. But it is 12 o'clock. I let people go get some lunch. I heard a noise here as well. I think it might have been my stomach. So I will stay online if anybody wants to chit chat about anything, but otherwise, thanks for coming. Hopefully this was fun and you learned a few things. And most people did sign up for all the workshops. So I hope to see most of you back next week.